I welcome you to another video of data compression course. In this video, we will learn about arithmetic coding, which is one of my favorite data compression coding scheme. Just like Huffman coding and Shannon coding, arithmetic coding is also an entropy encoding scheme. By entropy encoding, we imply that we assign codes based upon the probabilities of symbols. However, unlike Huffman coding and Shannon Fano coding, arithmetic coding is not a prefix coding. So some of the advantages of prefix coding is that prefix coding is very fast to decode. So that advantages are not part of the arithmetic coding. We know that the Huffman coding is an optimal prefix coding. That means no prefix algorithm can ever outclass Huffman coding. However, arithmetic coding, which is not a prefix coding, performs better compression as compared to Huffman coding. So I'm writing here better than Huffman, but it is better than all prefix coding. You might be wondering that how come arithmetic coding outclass Huffman coding. So the reason is that in Huffman coding we assign code to each symbol, and then in our data we replace every symbol with the code. In case of arithmetic coding, we don't assign code to each symbol. We assign a fractional code to the whole file. Now, in case of Huffman coding, each code assigned to a symbol is of integer length. For example, a symbol A might have a code of length 2 and symbol B might have a code of length 3. And in case of arithmetic coding, because the whole file has a single code assigned to it, which is a fractional code, so each symbol itself, on average, gets a fractional code. So it's possible that symbol A code is of length 1.7 bits and symbol B code is of length 2.3 bits. So that's how arithmetic coding beats Huffman coding. You might also be wondering that why there is not many algorithms that use arithmetic coding, whereas many algorithms like deflate use Huffman coding. So the reason is that arithmetic coding is slower to compress and decompress. At each step, it has to compute lots of values. So it has a high constant factor that makes it slow for encoding and decoding. Now, in order to understand arithmetic coding clearly, I will clear the board and then we will do an example. So here is our example. We have a set of symbols A, B, C, D and their corresponding probabilities. Probability of A occurring in our data is half, 1 over 2 or 0.5. Probability of B occurring in data is 1 by 4. Probability of C is 1 by 8 and probability of D is also 1 by 8. So the sum of probabilities is equals to 1. In case of Huffman coding, we could start assigning codes to each symbol based upon this information. However, in case of arithmetic coding, we cannot start calculating codes right away because in case of arithmetic coding, we don't assign codes to each symbol. We assign a single code to the data that we have to compress. So we need data in order to start our compression. Assume that in this case, our data that we have to compress is A, B, B, C. Now we have full information. We have our symbols and their probabilities, and also have our data to assign a single code. So let's start. First step is that we create a unit interval from 0 to 1, because the sum of the probabilities is equals to 1. So we create a unit interval from 0 to 1. So I write 1 here and 0 here. Now I have to find subintervals based upon the probabilities of symbols. I know that the probability of D is 1 by 8. So I write here 1 by 8, because from 0 to 1 by 8 is the portion of symbol D. I write D here. So this is the subinterval for symbol D. Usually we include 0, but we exclude 1 by 8. So we can say that the subinterval for D is from 0 to 1 by 8. So 0 is included, but 1 over 8 is excluded. Similarly, we have to find subintervals of each symbol. Next, we have C. C's probability is also 1 by 8. So once again, we have another interval, and we will add C's probability in D's probability, calculating cumulative probability. So we will get here 2 by 8. So both of those intervals are of same size, but we have written here 2 by 8 because we have added the probability of C in the probability of D. So this is the interval for, or subinterval for symbol C. Next, we have to find subinterval for symbol B, and B's probability is 1 by 4. So we have to add 1 by 4 in 2 by 8. So we have to add B's probability 1 by 4 in the ending range of the last interval, which was 2 by 8, and this will give us 1 by 2. So we write here 1 over 2, and this is the interval for B, and the rest of it is obviously the interval for symbol A. So this is the step which we have to do always, irrespective of whatever the data we have to compress. But then we have to drive further these intervals based upon the data that we need to compress. We need to compress first A. So we know that here is the subinterval for A, and we will zoom in this interval. Let's zoom in A's interval. And so the starting range of our new interval corresponding to the A's interval will be 1 over 2, because A starts from 1 over 2, and the ending range will be 1 because A ends at 1. So we have made this new interval because our data to compress was A. Now we have to divide this new interval based upon the probabilities. How can we do that? We first see what is the length of this interval. So it is 1 minus 1 over 2 is equals to 1 over 2. So this is the length of our new interval. Now we have to find 1 over 8 of 1 over 2 because D's probability is 1 over 8. But in this new interval, which is of length half, we have to find what is 1 over 8, which is 1 over 8 times 1 over 2. So D's probability in this interval is 1 over 2 times 1 over 8, which will give us 1 over 16. But we can't write 1 over 16 here without adding 1 over 2 in it, because we are writing here cumulative probabilities. So finally I have to write 1 over 2 plus 1 over 16, and this will give me 16, and 8 plus 1, 9 over 16. So I will write here 9 over 16, and this will be the interval for D. If you are able to understand this step, you have understood the whole algorithm, because we have to repeat this step again and again, and we have to basically zoom in the subintervals and continue to zoom in as long as our data is not finished. So let's repeat this step again so that you understand it clearly. Next we have to find the subinterval for D. We know that this is the length of our new interval, which is half. We know that the probability of C is 1 over 8 once again. So we multiply probability of C, which is 1 over 8, with 1 over 2, we will get 1 over 16. So in this range, probability of C is 1 over 16. But now I have to add 1 over 16 in 9 over 16. So because we are calculating cumulative probabilities, so I will add 1 over 16 in 9 over 16, and this will give me 10 over 16, or I can simplify it by 5 over 8. So I will write here, which is this one, and this is equals to 5 over 8. Next I have to find the range for, or subinterval for B. I know that the size of my new interval is half. Then next I have to find the new probability of symbol B in this subinterval. To that end, I will multiply 1 by 4 by half, and this will give me 1 over 8, and then I will add 1 over 8 in 5 over 8 because I am calculating cumulative probabilities. So 1 over 8 plus 5 over 8, and this will give me 6 over 8. So I will write here 6 over 8, or I can simplify it by writing 3 over 4. So let's write 3 over 4. And that's it. So I'm done with the second step, which is corresponding to our first data element A. But I have to repeat this step again and again. So let's clear this portion of the board, and then the next step corresponds to symbol B. So here I have to basically process my next data element B. To that end, we will zoom in B's range. So we will zoom in the B's subinterval. So let's zoom in. So the new interval will start from 5 over 8 because B because the B's range started from 5/8 and it ends at 3/4. So I will write 3/4 here. We have zoomed in. Once again, the same steps. I have to divide it into multiple intervals based upon the probabilities of A, B, C, D. So the first, I will divide it. I will find a subinterval for a symbol D. To that end, first I will find the length of this new interval, which is 3/4 minus 5/8, and this will give me 6 minus 5 is equals to 1/8. So I will save this for my future calculation. This is the length of my new interval that I have to divide into multiple subintervals. First, I have to find that what will be the ending range for my subinterval for D. To this end, I will multiply the length of my interval, which is 1/8, with the probability of D, which is also 1/8, and this will give me 1/64. But I can't write 1/64 here because I'm writing here cumulative probabilities, so I will add 1/64 in 5/8. So finally I will write 5/8 plus 1/64, and this will give me 24 plus 1, oh no, not 24, 40 plus 1 is equals to 41/64. So I will write here 41/64. That's the ending range for my subinterval for symbol D. And now I will continue the same step. My length of the subinterval will remain 1/8, and now I have to calculate the probability of C in this subinterval. To that end, I have to multiply probability of C, which is also 1/8, with the length of my interval, and I will get once again 1/64. And finally, I have to calculate cumulative probability. To that end, I will add 1/64 in 41/64, and this will give me 42/64. So this is the range for symbol C. Next, I have to calculate the subinterval for symbol B. My length of the interval remains 1/8, but here I have symbol B, whose probability is 1/4, and I have to multiply 1/4 with the length of my interval, and this will give me 1/32. But then I have to add 1/32 in 42/64. So 42/64 plus 1/32, and this will give me 64. 42 plus 2 is equals to 44/64. So I will write here 44/64. This is interval for symbol B. And now for A, I don't have to do any calculation. If my other calculations are correct, then this is the subinterval for symbol A. And we are done by processing our data element for A and data element for B. And similarly, we have to calculate our data element for B once again. To that end, we have to zoom in once again. So we zoom in on B. The calculations are once again it's the same. So instead of wasting your time, I will stop the video and complete the calculation, and then we will see how to encode and decode. So stay tuned. So I have completed the calculation for another subinterval. For symbol B, we have zoomed in on the range of symbol B and then divided it into multiple subintervals based upon the same calculation that I have shown you earlier. But finally, we have to find another range for symbol C. To that end, we don't have to do much calculation. So what we have to do, just write that range. So we have to zoom in on C, and we know that C range starts from 169 over 256 and it ends at 85 over 125. And we can stop here. We don't have to calculate sub-intervals of symbol C, because C is our last symbol. So the compression of string A, B, B, C is a fraction 169 over 256. So our compression result is 169 over 256. Obviously, we have to convert it into binary and then store in a file. But this is the result. Decompression is very similar to compression. So if you have understood compression, you have also essentially understood decompression. This number here is approximately equals to 0.66015. In case of decompression, we don't know our original data because our original data is replaced by this number. But in the header of our compressed file, we have to save symbols and their probability, and in the body we will save this number. Now, in order to decompress, we will create these ranges once again. So how we will be able to create these intervals without knowing our original data? We will rely on this number. First, we will make this unit interval based upon the probabilities that will be saved in the header of our compressed file. Then we look at this number and see this number lies in which subinterval. This number, which is 0.6015, lies obviously in this subinterval because it is larger than 0.5 but smaller than 1. So we will zoom in this subinterval. Once again, we will repeat the same procedure again and again. We will see this number lies in which subinterval and we will zoom in that subinterval. We will continue doing the same thing, that for example this number lies in this subinterval. Then we will zoom in and this number 0.6015 lies in this subinterval. So we will zoom in. Once again, 0.66015 lies in this subinterval. So we will zoom in once again, and at the end, as soon as this number comes at the start of our range, we will stop, because now we have processed our complete data. And this number 0.66015 is now at the end of our range. So we will know that our original data that we have compressed was A, B, B, C, based upon how we have zoomed in. That's it. This is our beautiful arithmetic coding. I hope that you were able to appreciate its beauty, and I'm sad that it is not being used as much as it should have been used because it is a bit slow. So that is it for this video. See you next time. Bye.